In this video, I'm going to talk a little bit about some important things with lines. So first, the first question here is, what is the slope of the line connecting these 2 points? So I have this formula for slope. My y2 and y1 are just two of the y coordinates. X2 and x1 are two of the x coordinates. So I'm going to call these two the ones and these the twos. So I'm going to do 5 minus -3, and be careful with the negative signs there, over 4 minus 2. So y2 minus y1 over x2 minus x1. This gives me 8 because this is really like 5 plus 3 over 2, which simplifies to 4. So the slope of my line is 4. To find the equation of that line, and we're going to use this format here, y equals mx plus b. I already know the slope because we just found it. I already know an x and a y because that can come from either of the points. I'm going to do the one that doesn't have any negatives in it. So I'm going to use the 4, comma 5. And I'm just going to plug those in and then I can solve for b is the missing thing. So I have y equal, I'm sorry, I'm going to substitute in for y. So I have 5 equals slope of 4 times my x coordinate is 4 plus b. So 5 equals 16 plus b. Trying to solve for b, so I have to subtract 16. So then I've got -11 equals 0 plus b. Don't really need the 0 there. So b is -11. So putting this all together now, my general equation to fit any point in there is going to be y equals 4x minus 11. So the key is I put in the numbers for the m and for the b. I leave x and y as letters in my final equation there. So that's the equation for that line. Now, if I want to find an equation of a line that is parallel to that and through the point 1 comma 2, I'm going to stick with that slope intercept form. So parallel means same slope. So I know right away that my slope is going to be 4. I also, once again, have an x and a y that I can plug in. So I'm going to say, I'll just write here, y equals mx plus b. My y is 2 from this point here. My slope is 4 because it's parallel. My x is 1. And once again, I'm solving for b. So 2 is equal to 4 plus b. Work to get that b all by itself. So -2 is equal to b. So now I can put this all together. And my equation here is y is equal to slope of 4 times x minus 2. So this is a line with the same slope, different y-intercept, so it's going to be parallel to this original line. So these two are parallel to each other. Next, it's asking me to find a line perpendicular to the original. So this is going to have a slope that is the opposite sign and reciprocal. So my original, let me just write that, opposite sign and reciprocal. So my original slope was slope equals 4. This perpendicular line has to have a slope that is negative and the reciprocal. So we could think of this 4 as being the same as 4 over 1. So flip that. It's going to be 1/4 and it's going to be negative. So this is the slope I'm looking for now. And I want to go through the point 8 comma 3. So for this perpendicular line, I have m equals -1/4. The x and y I'm going to use are the only two I know at this point. So I've got x equals 8, y equals 3, and I'm going to once again use that, oops, slope intercept form. So I'm going to use y. Let me just see if I can, yep, let me just move this out of the way a little bit. So I'm going to once again use my y equals mx plus b. Y is 3, m is -1/4, x is 8, and b is what we're solving for. So I have 3, -1/4 times 8. I'll just write it down over here. We can think of that as 8 over 1. This cancels, so I get -2 over 1, which is -2. So 3 equals -2 plus b. To get this b by itself, I'm going to add 2 to each side. cancels out. And I'm just going to give us a little more space again. So I have 5 is equal to b, or b is equal to 5. So now my equation is going to be y equals this perpendicular slope times x plus b. So this is an equation of a line that is perpendicular to the original. Our original was that y equals 4x minus 11, I believe. Yeah. So this is perpendicular to y equals 4x minus 11, passing through that point 8 comma 3. Last thing I want to talk about is how to change this perpendicular line, this particular equation, into standard form. Just so you can see an example of that. And standard form is this one here. Let me just use a different color so it stands out. So standard form is ax plus by equals c. So this means, so a and b are not fractions. These are integers. Integers, a, b, and c. Um, and the a is going to be positive. So those are just a couple rules about that standard form. So coming back down here, to make this equation look be in this form, ax plus by equals c, the big thing it means is that I need to have no fraction. So I'm working with this equation, y equals negative 1/4 x plus 5. So I can't have fractions. I need the x and y together on the same side of the equals. And x has to be positive. Or I'm sorry, the coordinate of x has to be positive. So here we go. So let's get rid of the fractions first. So I have a negative 1/4. So if I multiply everything by 4, that's going to take care of that. But I do have to remember to do every term just to keep everything in balance. So this cancels. So after I multiply by 4, I'm going to have 4y equals negative x plus 20. I want to get that x to the other side, so I'm going to add x. So that cancels out, and I have x plus 4y equals 20, and that does it. That is my standard form. So my a is 1, b is 4, c is 20, all good. So that's taking that equation that was in slope-intercept form and putting it into standard form. So that is a bunch of different things you can do with lines. So I will stop there for now. Thank you.